Okay, let's also do this, or I can search on my phone. Because someone told me that this session can be watched live if I search up the name.
Are you trying to like do the Inception thing where you watch yourself on
I don't know.
watching yourself live, watching.
If I put it up on the screen, yeah. Oh, it is there. Hello? Oh, yeah.
Are you watching yourself live?
Yep. Okay. So people can watch it while I'm doing this. Okay. So density is like mass over volume, but they treat it mass over area. So then mass is equal to density times area, which is a double integral of density dx dy. Because since this is area, right? The double integral of area will just give us normal area, density times area leads to mass. Yes?
I totally watched that video.
What's that?
These are the videos.
Are they?
Yeah, this is a video.
Yeah, I totally watched it.
Was that a sarcastic? Okay. So I'm just gonna write the formulas. They're on your dyno slides, but like I'm gonna go over double and triple integrals, but just to make sure that you guys know the formulas, so I'm gonna write them on here. So the first moment m of y is equal to the double integral of the region x times dA. X times rho dA. So these are something that you should memorize.
Should?
Yeah. With respect to x, we have the double integral of y, rho dA. That's not rho, but that's the symbol. So like, moment with respect to y, we do x in here. So that's sort of a backwards thing. X bar is equal to my over m. Y bar is equal to m x over m. So on the exam, they'll ask you to find this stuff, so you should know these formulas. The second moment is Ix. For Ix, we have the double integral of y squared rho dA. So then Iy is a double integral of x squared rho dA. Iz. What do you guys think Iz is?
It's probably going to be the integral of x versus y squared.
Yeah. I'll move it up. X double integral of x squared plus y squared times rho dA. So, do you need to see that? So just I'm writing these because you should memorize them. So.
Why is z x squared plus y squared? Is that even
That's like
z equals that?
z squared sometimes, like a triangle. X squared plus y squared equals z squared.
Yeah, I see. Put that here in.
Why not? I think that's why, but I could be making that up. Probably not. Because we're doing dA, and dA is a function of dx dy, right? So if you want to convert it into the three-dimensional z aspect, that's probably why. And then the radii of gyration, that's something you should know.
Well, good Mediterranean place with gyro.
That's a gyro. Something completely different.
for Rx, it's equal to Ix divided by M. Ry is equal to the square root of Iy divided by M. And R's
So are all of these going
origin.
to be numbers?
What?
Like, are all of these going to be like integers or something?
Yeah.
So we
Is
can
it-
get like,
Oh, we need to memorize all
is
of
that
this.
R0
Yeah.
or RZ?
0. Like the origin. It might be Z. I don't know.
The notes is RC.
Is it R of Z?
Yeah, I mean, in the video.
Because on my notes from last year, it's R of O, but I'm sure R of Z is works. But essentially, the problem will ask you to find I of X, M, and then you find R of X, something like that. So it'll, probably guide you that way. But you should essentially know that I of X is with Y squared, and I of Y is with X squared, and that sort of thing. Yeah? So that I just quickly wanted to mention, so then we can move on to double integrals. Okay. This problem should cover double integrals pretty well. So you can do double integrals, and you guys remember the problems where you had to break it into two regions, right? Sometimes you have to break it into two regions because
That was like two integrals, double integrals.
two double integrals. Let me find that problem actually, because that one's better. Okay. We have the line y equal to x plus 2. So this is a 2. And then we have the line y is equal to x squared. Okay. So what's the first thing that we should do if we are given this right here? And we're told to find the region area. What? No, we're going to cover both ways. The first thing that you should do, though, is find the intercept. Okay? So we set x plus 2 equal to x squared. So 0 is equal to x squared minus x minus 2. So what would our two factors be? You guys want to say? X minus 2, x plus 1. So then x could either equal a 2 and equal a negative 1, right? Well, the negative 1 would be in this region. And the graph goes like that, right? We're not interested in that, so we don't care about that. When x is equal to 2, y is equal to a 4. Okay? So then the point here is 2 comma 4. So now there's two ways to do this. We could enter through the and go up, or we could go enter from the left and go right. Okay? Which way is the optimum way?
The bottom one.
Going up, because then we can cover both curves both times. If we go from the left, we will need to separate into two integrals. Okay?
Why do you need a double integral?
Because we're finding the region for which it integrates. So it's like finding the area.
Yeah,
Yeah, why can't you just do the regular
Yeah, I was
shit?
thinking, like, why
Because-
did the regular integral?
Oh, because you have two different.
No, we did this before.
Yeah, this
Because
is like a Cal 1 problem.
you did the top minus the bottom.
Yeah.
Yeah, what's wrong with that?
Because this leads on into triple integrals. I think that's the idea.
Not an
So
answer.
it's just like
'Cause with triple integrals, you obviously can't do top minus bottom and stuff.
it's like a second.
Yeah.
I agree.
Would you get the same answer though?
You should get the same answer.
Check it out.
Wouldn't we just integrate x plus 2 minus x squared?
Yeah.
From, what is
We
it?
already did this in Cal
0
1.
to 2.
0 to 2.
I think he said it's.
It's because you need to learn what it means to have, instead of limits in the integral, to have actual equations in the integral. So it's like a segue, I think. You can ask Hal and Ross on this. Okay, so if we're going from the bottom up, would we do dx dy or dy dx?
dx dy. No, dy dx.
You would want me to do what?
I don't
We
know
would wanna
why
do-
did I do dy dx?
Because the change is happening in the y direction,
So you
essentially.
could-
Essentially, we're going through the y direction, up or down, so we do dy first. That's essentially the way.
Explain the arrow shooting concept.
We're going from the bottom up, right?
So are they just like doing like the higher limit minus the bottom limit by like you're just shooting arrows to represent that?
Because are you asking like why I drew an arrow here? I mean,
No, like I don't.
like it's not really important at all. It's just knowing that we're
as long
going.
as you understand like what
Yeah.
the limits are, you're fine.
Okay. So since we're going from in the vertical direction, we do dy dx. And what would, one second. They have the function x there. Well, let me look at, okay, so what would our lower limit be for y? X squared. Our upper limit would be x plus 2. And then for our limits for x, we'd be going from 0 to 2. Don't know why I'm blanking out, but what would the function be?
Then you just leave it.
Yeah.
It's just dy dx.
There's an x there.
What? You just put a 1.
Yeah, that'd just be.
Just put a 1.
They have an x there.
I think they would give you it though.
Yeah,
Yeah,
They would give you the function.
yeah, they give you the function.
they do.
Where?
Because
They say
Oh. Okay. Well, it is x, but I think the reason now they probably want you to do it double integral is because imagine this as in like a 3D shape. Although you could do it with just single integrals if they told you the function x. But imagine as this like a 3D shape where the curve coming out is x, and we want the double integral on the xy plane. Does that make sense? It goes back to that analogy I used last time. Like, if there was a cloth here, you'd have maximums and mins, right? The curvature of the cloth is, say, x. And then we want the area, like the shadow of it on the xy plane. Does that make sense? Just, I know.
They're just gonna say put x in there.
Yeah, they'll probably give you x as the. Are you guys all good with it or no?
I don't know. Are you sure they gave it to you?
I think they do give x here. Yeah. They want like, there's a 3D shape here with the function x. We want the shadow of it in the xy plane. Did that make sense? I think. Okay. we're just going to keep going now. Okay, so the way to do a double integral is we take the integral of whatever is in here with respect to y. Essentially, it's like, you know how we do partial derivatives of, say, y? We treat everything as like a constant except y or something. So it's sort of like that. X here is essentially ignored. Since there is essentially a 1 there and there is no y, the integral of 1 with respect to y is just y. So then we have from 0 to 2 of xy, and the limits on y are x squared going to x plus 2 dx. So then we take we treat it like a normal integral, and instead of limits we have functions. So then it'd be x plus 2 minus x squared. So then we'd have from 0 to 2 of x times x plus 2 minus x squared dx. Do you guys see how we got there? Yeah. So then it's x squared plus 2x minus x cubed. You do the integral and plug in. I'm not going to solve that out.
Lazy.
It's from your class though. So.
Oh, dang.
Real quick.
I had it. I don't care.
Do you want me to rewrite it?
No.
Or I'll just write it.
Thanks.
Because we just substituted in minus the lower limit. Now let's do it if we were going from left to right. We'll call this region 1, we'll call this region 2. For region 1, we have the integral. This time we're going left to right, so we have dx dy. What is our left limit if we're looking at region 1?
Wait, why is X?
X is just a function they told us.
Oh, so do they? How would we get?
They tell you.
No, what did they say?
Yeah, how would they?
How
say
did they
X?
make words?
'Cause I'm
In a 3D one, you won't, but in a double integral. Oh, they actually write out the double integral for you on this.
No, they
Oh,
didn't.
but they tell you like f of xy is equal to, so in this case, they give you that.
Okay.
Okay. But say we're going dx dy and we're looking at region 1, what would my lower limit on the dx be?
X equals square root of
Well,
the lower.
so we're up
Yeah,
here.
you're going that way, so it'd be X equals.
We have to have two double intervals.
Y minus 2. X is equal to y minus 2.
Why didn't X equal
Why is that the
minus
low?
two?
If we're oh,
We're going from left to right.
why?
We're looking
why
at
is
region
that
1.
Region 1. I did mine.
You did it backwards.
Yeah, why
It-
went the lower one?
Why are you doing it wrong?
It doesn't matter which is region 1 or 2, guys.
You're right. You're right.
Um,
I just want to give you a hard time.
X is equal to y minus 2. What is the left side? X is equal to
Square root of y.
square root of y. And what are the limits on y?
0 to
No, 2 to
God.
Or- no.
Yeah, 2 to 4. For region 1.
From 2 to 4. Yeah. Because the second integral we're looking at just y from bottom to up. So it's 2 to 4.
You need a catchphrase. What kind of catchphrase do you give me?
Plus,
I think that's all you really need.
Oh, another thing is
if we're looking at the bottom, y is equal to what? X is equal to 0. X is equal to square root of x again. Square root of y. And then y, guys, from 0 to 2. If you understood like how we got these limits, then doing triple integrals is exactly the same process.
So whichever direction your arrow is pointing, that needs to be the important.
And it's always gonna go like from
Left to right.
up, and it's gonna go
Up. It goes up and then it goes.
Yeah, like top minus bottom, but we show the arrow like
because it's gonna be final minus initial.
like
so.
yeah. So that what? No, you don't need to show that.
Same, honestly. Actually, that was my dad.
But did this make sense?
Yeah.
This is the function they tell you f of x equal to x. That's like equal to z coordinate, and then that's the shadow of it on xy. Okay. Do you guys have this copied down? Because we're gonna
No.
Yeah. we're gonna do a triple integral now.
How do you know how to draw the?
Yeah, no one does. I'm just kidding. That takes practice. Drawing a triple integral picture.
Yeah.
That's so key.
Someone just submitted it, and I was like,
Yeah, I was like, what?
It's like graphics all over.
it's a word.
It's-
Graphics is just like projecting stuff with a triangle.
It's like figuring out.
I feel like drawing the thing is like incredibly integral to getting the entire problem correct.
It is, and then it's hard to draw them too.
Yeah.
And then sometimes you just have to
If you
mess
draw it
around
wrong,
with it
don't
and
you
like
get everything
take your
wrong?
time.
If you draw it wrong, the whole thing's wrong because you don't know what you're doing correctly.
Yeah, and you get an incorrect answer. They will probably give you some points, but not the majority of the points. But that's the thing about Calc 3. That's why it's that hard.
How many times do we have to draw 3D stuff?
The whole semester left.
Yay.
Nuh-uh.
I think so.
I
Nuh-uh.
like always lose points on my drawing.
You guys will do practice with that. Don't worry. But for this problem, it's a pyramid, essentially. I'm going to erase all of this. Your dyno, and I think it's on video. But it's a good practice, again, looking at the limits.
Is this the one from your notes?
So this is a good problem, just seeing how to draw. I mean, doing the limits, but triple integral. X plus y plus z equal to 1, and then this is 1 comma 0 comma 0 0 comma 1 comma 0 0 comma 0.
Could you draw that for us?
This one? Yeah. The way you would draw it is that looking at the xy in plane, right? So the equation is x plus y plus z equal to 1. The xy plane, there is no z component, right? X plus y equal to 1, y is equal to x minus 1.
Oh, that's the line.
That's the line. Did I subtract that right? 1 minus x. Right? The intercept is y1, and the slope is negative x. And then you do that same thing with all other sides.
Okay.
That's actually a good question. So did that make sense? And then, so this is the equation we're given for the entire thing. If we are looking at the xy plane, we can make z equal to 0, right? So then x plus y equal to 1, y is equal to 1 minus x. Is if you imagine the yx plane, you draw that line. Now looking at x is equal to 0, we have y plus z equal to 1. Z is equal to 1 minus y. Looking at the zy plane, 1 minus y. That's that line. Why are you shaking your head?
Oh man, that's just a lot. It gets worse than this.
It does get worse than this, but this
It's
is like
so much worse than this.
this is just one way to picture it.
I'm literally having to rotate each axis in my head.
Yeah, and then you just can have a figure that's connected.
Wait, so x equals 0.
Would give us the zy plane.
Oh, so you just put in, you put in 0 for x.
Yeah.
Right there, and that's, okay.
This is the easiest problem.
This is the easiest problem with this. But do you guys get the style of thinking that you need to do?
Just that.
Like imagine one plane at a time sometimes. Yeah, sometimes. But to find the volume of this, okay. I think that's the way they did it. So you could do them in any order, right? So in this one, we don't need a special function here because we are already looking at it in 3 dimensions, okay? We're trying to find the volume, and that's just the integral of z times y times x, right? So the integral of dz, dy, dx. So x, y, z. So what are the limits on z? If so, starting from the bottom and going up, if we were to shoot up, our lower limit would be 0. And then we're coming out the top, right? So what is z equal to with that equation?
Is it that
1 minus x minus 1, right?
why the what? I solved for z. That's all.
Yeah.
Okay.
Because z is governed by that equation. All of them are. So if you were to do dx first, we'd look solve for x.
So then do you draw the plane for x and y?
Since we now have it in terms, we already did it in terms of dz. Looking at the other sides, we need to redraw it in terms of x and y now. And that was this figure, and we found that the equation was y is equal to 1 minus x when z is equal to 0. Okay. So then so next is dy. What are our limits for dy?
0.
0 to 1 minus x.
How come we don't just put 1 and we put 1 minus x?
What? Why would I put?
I don't know.
Because it's 0
Because you're
lower
just
limit.
going through the whole function, you're not just going to tippy top.
Yeah. Okay. For x, what are our limits? 0 to 1.
Why is that just 0 to 1?
Because then now we're essentially looking at, why did I do that? We're looking at x-axis going from 0 to 1. We've already taken care of the change in y, the change in z.
Well, but if you go like this, you shoot your arrow, you're going to go.
Well, we could have done dx, dy though. Then we would have looked at x first.
So the last thing is always just numbers.
Because if you have equations in the last thing, you didn't solve the problem. You're going to have x or y or z in your answer.
Okay. Oh, I see what you're saying.
So how'd you get 1 minus x minus y? You just like rearrange the equation?
Yeah, it's equal to z, and that's the curve. That's the upper curve,
The upper curve.
or whatever the surface is.
So the arrow enters from the base of the triangle
Well,
bottom?
yeah, like we looked at z first. That's what we did from the base to the top. Like we could have started with y
Yeah.
going from the left to the right, or from back to forward for x. Yes? And do you guys want me to solve this out?
No.
Well, why don't you have a function?
Because
Is it just gonna be functionless?
yeah, because our function, we're trying to find the volume, right? We don't need a function. Volume is the integral of dz is z.
Yeah.
The other, yeah, the reason we had a function was because we wanted the xy plane of that function. Okay? So if we wanted in this problem just the xy plane, right?
Right.
We wanted
Oh, your
the,
function would be-
so then we have a double integral 1 minus x minus y dy dz. And in the end, these turn out to be the same.
So generally, do you not have a function for triple integrals like in this unit right now?
I don't think so. I mean, yeah, you don't. That's what I think.
We don't have a
Not yet.
Because the function, like we are working, we have a three-dimensional shape. The equation for the top is given, so that's going to be our one of our limits. There's no other function that guides the shape.
We just put in 1 for that blank spot you have right there?
Yeah.
We don't put in z
No,
plus- oh.
No, we don't put in anything because the limit is already part of the integral.
Should
So, yeah.
For every, like, if we do it differently, so if we do dy, dz, dx, would we get the same answer? As,
Yeah. They're going to ask you to do multiple ways. Like for this, they say dx, dy, dz, and then rewrite it with dz, dy, dx plus, or whichever way. Because in class you found all 6 ways, right?
Yeah, we did also.
Yeah.
We probably did. It was a mess.
Because you did dz, and then you do dz, dx, dy.
Like not.
But you could do 6 ways, like dz with dx, dy, and then all the 6 combinations. And they would give you the same answer. You just have different limits at different times. But then let's go to a harder problem.
That's what I like to do.
Can we try and like work together to draw it? Because I have a really hard time. Like,
Yeah, we can do that.
And we're totally screwed if we don't have one.
Let me try to find.
Completely irrevocably.
Don't worry, we'll get there.
So is like the whole page
So cute.
one of these
That was
problems?
his attempted ingredient.
What?
Is one of these problems like a whole page? Like one row?
No. Like they don't actually ask you to solve it. They're just asking you to write the limits for this old exam, which is nice. Because, well, on your exam, they'll ask you to solve it probably.
Why do we have to solve it? It's probably harder now than it was.
what is?
Yeah.
Top 3.
I thought calculating was easy, but now it's hitting the fan.
Okay. This problem is, I'm not going to, so they give you the graph, but for our purposes, I'm not going to draw the graph. So then we can learn how to draw on our own.
And if, would they just give us like that plane, like x plus y plus z, and we would have to draw it, or would they give us like all of them?
They ask you to draw it.
And they just give you that,
They give you the equations.
just the x plus y plus z.
It depends on the problem. Like the example we're going to do right now has 2 equations. So our 2 equations are y is equal to x squared and y plus z is equal to 1. Okay? So this tells us that the equation for the xy plane is y equal to x squared, right?
Right.
So we can draw that, right?
Is this the exact problem we did?
Yeah.
Probably.
That's okay.
Yeah.
Um,
That's-
all look for a different one after this one.
But I already know what it looks like, so I feel like I cheated.
So there we have y equal to x squared. And then on this side, we would also have y equal to x squared. And we have z is equal to 1 minus y, right? So then you have to imagine, well, the intercept up here would be 1. So this figure goes up to 1. And then in a three-dimensional way, there's a surface here.
How do you know? Oh, because you just plug in zero.
You just plug in
0 for y. So there's really no way for me to show it but to draw this out like that.
Yeah, that's the problem. Like, why doesn't it just go straight down to the y-axis?
Yeah, that's what I thought.
I just drew a straight line from the z to the y, and then I was like, this is a really weird, kind of sharp triangular thing.
I did.
Because if you look at it from a zy perspective, though, it is a straight line. From that perspective, it is yz. That is the what you'll see in that plane. And then when you add in the x dimension, it's a parabola back and forth.
Wait, so those are actually straight lines?
Is it?
These lines?
The x, y, z ones.
What does that
Yeah,
mean?
like in the plane where x is equal to 0 and we are in the yz, we have a triangle like that.
Yeah, I see
Because
that part.
it looks like it's curved.
It's curved when we enter the the x dimension. Because then it's like a parabola that's decreasing the distance from around here. This should be curved here. Something like that.
Yeah, but why is that curved?
Because that's the rule it's obeying in the xy plane. We have to maintain that parabola shape in the, xy plane, yeah.
You have to maintain the parabola shape in the x, y?
Yeah. So then if we are going, whenever we're looking at it in the xy plane, we have the shape xy plane, and then it's something like that. And we are maintaining that parabola. And then when we come out into the z shape, it'll be 1 minus y.
But isn't z equal 1 minus y just like a straight line?
Yeah, so this is a straight line in that plane. And even in this third dimension, it is a flat plane. But it's like on the sides, it is parabolic.
Wait, why did you draw it?
Yeah, that's what I was asking. Like, why on the sides does it appear parabolic?
You grab the front.
Because the parabola is on the XY plane. Like that's why it should show it. Picture they have on Dino, but
Would you try and like graph all of the different like 2 dimensions and then try and go into
that's
dimension, or
you could do that.
would help? Or do you think it would
Like it depends on the problem.
I
Like
don't think I can get from there to there.
the first problem we did, it helped to do it on the 2 planes, right? This one. Okay, let's look at that. So we have that y is equal to x squared on the xy.
Right.
So in reality, it's also negative x direction, right? But for now, like, we're going to ignore that, okay? So then this is coming from here. Y is equal to x squared. That's that line. If there was, essentially, this is not on that plane. It's also a 3-dimensional surface, right? That's following that rule.
But this is what I drew right here.
So then
Whoa.
this has to be maintained while every time we're decreasing, we have.
So would you find that by like where they intersect by just doing an intersection point?
Yeah, you also need to do intersection points, the tougher the graphs get.
Is that what they do? Did they do that?
In this, it was obvious it was going to be 1, when z is equal to
when
0.
Like 0, yeah.
Yeah.
When z equals 0.
Can you explain the maintaining part again?
Like this y, z is equal to 1 minus y, right?
Yeah, that straight line. That's
That needs, so in a 2-dimensional, it is a line, but in a 3-dimensional, it's a plane, right?
Yeah.
And that plane needs to be maintained at that angle throughout.
yes, throughout like all the
Yeah.
x's.
But then we're cutting it into a parabolic shape on the sides so that on the xy plane, we always have the shadow is always y equal to x squared.
Oh, that makes sense now.
So it is a lot of just like sitting there and trying to understand it, like just trying to picture it. And you have to make sure that you do actually get this. Like you're at the point where you can't like BS your way through calculus.
We can't do this.
Um,
I don't think you can ever.
Yeah.
Like, when have I ever? Okay.
So like what are they talking about in class and they're like, enter this way, and then you enter this way, and then you enter
Yeah.
this way.
Because
No, it makes sense.
if we're entering, so first they'll tell you like we're looking at a dz first.
Yeah.
So we enter it on the z-axis from like the bottom and then looking.
So like
Going
you
through
guys
the
are
top.
parallel to the z-axis?
Yeah.
Okay.
So then, let me see if they actually do this. Yeah. So from our lower limit, it's just 0 since we're only looking at it. Since the graph ends for this example when z is equal to 0. Okay. The base of it is there. Our upper limit is the curve that controls this plane, right?
Okay, yeah.
And that equation is this. So then we have 1 minus y there. Then we need to look at it from an xy perspective. Next we have dy. So we, from the bottom going up, the equation that governs it here is y equal to x squared.
If you're looking at like 3D, would you enter from like the left moving to the right?
Yeah. If this were dx dy, we do left moving to the right. Since we're doing dy first, it's x plus x squared, and then y is equal to 1 at the top. That you can get because z is equal to 0 on the xy plane. So then 1 is equal to y. Okay. And then the limits for dx are -1 to 1 because I told you this also extends behind.
And they'll tell you like which word the DZ, DY.
Yeah.
Would they start out by giving you like a full, like a full trigonometrical? They give you that, and then you draw it, and then you do other stuff.
Yeah. It totally depends on the problem, but for the one in class, they just leave a blank triple integral with dz, dy, dx, and you fill in the limits and stuff.
And then you do the drawing.
Do you usually have to evaluate the triple integral?
Well, how
No.
are you supposed to?
It depends.
It depends on the question.
And then, so on, okay, let me not go there. Do you guys understand how we got the limits on this part?
Yeah.
Okay. Now, on the old exam, they give you a v like that with dy, dz, dx. Okay? So then using that triple integral, and they tell you the limits. They don't give you a curve or anything. You look at the limits, and then you have to sketch it out.
No.
And then you take that sketch, and then do dx, dy,
That's
dz.
impossible.
Wait, so they.
I will go
so
over
they
that.
give you that, and then they like reverse it, and they're like, now draw
Yeah.
it this way.
So essentially, they give you this. They tell you to draw this figure, and then say we have to find dy,
I can't do it.
dz.
I can't do that.
Well, I mean, that's what the problem today was. They gave us those.
No, they gave us the equations and we sketched the graph and
But,
they didn't just
okay.
give us the integral without giving us anything.
Look, think of it this way. We are looking at dz, right? The lower limit on z is equal to 0, so you know that's the base. The function at the top is 1 minus y, so z is equal to 1 minus y, which was our equation that we used to govern the top portion.
I guess
Okay.
we can find
So
it.
you got that equation. Then we have this limit, y is equal to x squared, y is equal to 1. So you can draw a 2D figure first, and then try to translate it into a 3D figure or something like that.
So basically, when you're given, at least when you're given like two different equations, when you're trying to figure out what the limits for the things are, you just want to set them like do the equation so that you can see. I don't know what I'm saying.
I know where you were going.
I'm sorry. You want to like manipulate the equation so that what you're looking for, like for example, z equals 0 and z equals 1 minus y.
Yeah.
Could you do that without drawing it and just by manipulating the equations? Would that be right?
To
And just
convert it
set
into dy, dz, dx,
Yes.
you should draw it. Because we would know our y is equal to. Okay, let's do it with dy, dz, and then dx. You'll see why. You should draw it.
We do a whole new problem. We're not done with this problem. Why can't we be done with this problem?
Okay. Going in the y direction, what do we hit on this side?
A Kirby.
The z.
X squared.
It's x squared.
Okay.
That's our lower limit. Because that x squared is maintained throughout the height, right?
Oh, it makes the curvature.
What is our upper limit?
1.
Our upper limit is coming out this surface.
Oh no.
Oh no, z equals, it's 1, z, 1 minus z.
1 minus z. Okay? Now, it's not 1 or anything. So
Now we do z.
So z.
Are we going, how do you know,
From
So
bottom
then-
to top.
we need to do x and z figure.
how do you know if we're approaching z from the yz plane or the xz plane?
Now, since z is second, we have to draw a dx dz plane.
dx, dz, okay, it's always the,
Don't try it. Don't try it.
Okay, you can figure it out.
Okay, so z.
But wait,
Is it?
is it just like a parabola that's facing down?
Like this.
Yeah.
Yes.
Wow.
So what I'm trying to get that is you can't just see that it be a parabola like that without drawing it and just by looking at that. Okay?
Uh-huh.
So then our limits would be
Z equals. Z,
Okay. uh,
0.
z is equal to we found that z was equal to 1 minus y, right?
How does that make that shape? That does not make that shape.
Y is equal to x squared,
Ooh, keep holding it.
1 minus x squared.
Uh-oh. Okay. 0.
So we're going from 0,
Which way is the arrow going? Up?
because we're looking at dz next, right? So we're going from 0 to up, which is 1 minus x squared. Because we substituted in for y.
Then it goes from.
And then x goes from,
-1 to.
Yep.
It's like a fun puzzle. No, it's not. It's like a jigsaw.
so
It's like a giant Jenga. It's dangerous.
before you come to the SI section on Monday, because I know most of you will not even touch this stuff for the week.
No, we.
Are you saying? Are you giving us a lecture?
A lot of
we
people
tried
don't.
on Sunday.
I always do my homework on Sundays.
Okay, that's how it should be.
We all go to the library.
But
I'm trying.
make sure you actually sit and think this through. Okay. Don't leave any of this for Monday night.
This is
Gotta
really
do my
complex.
graph later this month.
Whoa.
Just do it
I
Saturday.
finished my graphics yesterday.
Oh my god.
And that goes to all the people watching. Make sure you think this through. Okay.
Thank you, Daniel.
And
What's
then
the practice exam on Sunday or Saturday?
probably be. Oh, this is a weird one. It'll probably be Sunday. Probably.
Don't do it Monday.
What did they draw here?
I got paid. Me too. Friday is today.
So there's like many different shapes that you can have. Oh, this is a weird shape too. So we have a surface that goes like that.
Okay.
Oh no.
Oh my.
No. What the hell?
You have to draw that out.
What the hell is
You have
that?
to draw that?
Yeah.
Is that what that is?
What? Z is equal to x q. I mean 3x, and z is equal to 4 minus x squared. Intercept, and the intercept at x is equal to 1. But did they do this in class?
No.
I have it in my notes that we did it.
Maybe it's from last year.
Yeah,
We might do it on
I figured.
Monday.
they might do it on Monday. But they said that. So this is your show your work probably.
No, we did our show your work involved the telescope in space.
This is the third show your work,
Um,
so you have more than one problem.
I didn't really know that. Yeah, I think
4 minus x squared. You solve that out. You find your dz.
Wait, so 3x. Is it equals 3x?
Yeah.
Is that just a line?
Yeah.
So then it's z over 3?
Now to find your x-intercept, we set them equal to each other. What happened?
She okay, so then it's divided by 3. I'm
Actually,
confused.
either.
Wait, so it's x minus 1 times x plus 4.
Yep.
Yay, 8th grade factory.
Actually, the 6th grade.
Oh, watch out. She was in an accelerator.
So we don't look at x equals -4 because we're only looking at the first coordinate octant.
I was like, I'll never get it in time. I mean, I'll
Oh,
never
so they
get
tell
it.
you that. Well, they should tell you this, but what is this shape anyway? It's a cylinder.
It's a cylinder?
They tell you it's a cylinder. So then this is like that curve,
Is that a 4 or a y?
but we're only living. It's an x.
That's not what
Oh, sorry, 4 minus x squared.
What?
That's a 4. Okay.
Wait,
So we
where's
found-
the y in this?
There's
Oh,
no
y
y.
is 0. No,
Yeah,
no,
y is
it's
0
not.
here,
It's out.
and then it's just a plane.
It's a 4.
This is a 4. Yes.
Where-
I thought we moved
where's
on.
the-
You don't need the third.
No,
You don't need-
the y does change.
Why not constant?
No, it's
The y is not just 0.
Why is it?
But you don't need to know the equation for you to solve it. Like, you just need to know the equations with x and z. So let's just go through it, and then you'll know this for class.
Draw it from scratch, erase the figure. Why did you give us the figure?
Because it would have been impossible.
We don't know how to draw things, and now we already know what it looks like, and so we're like, yeah, I would have gotten that, but no, we wouldn't.
Wait. Dan.
Yeah.
I'm so confused about about the y? Do you just not need it? But you need it for like one.
You okay? They could have given it to you, but essentially, what shape did we have in the background?
Well, you just
Well-
drew it. I didn't know that. How did I know that?
Because it was basically a rectangle, right? So the equation governing y was like y equal to 1 or something like that.
But it does change though.
We have to write the limits of
But-
the integral.
We'll go through it right now, and you'll understand.
Okay.
So they tell you that z is equal to 3x, right? Essentially, okay, without even further stuff, let's draw that. X and z plane, right?
Okay.
Z is equal to 3x.
Okay.
How would that go?
It's a line. And it's going like.
So this is a positive direction, remember?
It's gonna go like.
Something like that.
It's gonna go. Yes.
Wait,
Okay.
what are we doing?
We're drawing.
Z is equal to 3x.
I'm gonna.
Z is equal to 4 minus x squared.
Gonna go like this.
It is, what do you call it?
Right.
It's a parabola, or it's an equation of like a circle actually, yeah. Or whichever way you think about it, something like that.
How did you?
The radius is, it's a negative parabola, essentially at y. It's negative parabola with 4s y intercept, z intercept. Yeah. So x is equal to 0. The intercept is 4. It's a negative parabola. Let me see if they tell you the. See, they should tell you the limits for y. Oh, they actually do. Okay. They tell you the limit for y essentially. Okay. Y equals to 2. That means this figure is maintained until we get to 0, 2, 0.
If y equals 2, then how can you have anything that's not at y equals 2? How can I have stuff on the xz plane where y equals 0 if y always?
We don't have any y stuff on there. That's the limit for y. Okay? Y
Yeah,
will
like on the
always.
top of an integral or something?
So, let me try to explain this better.
But
Y equals to 2 is a plane that goes like that.
Yes.
Okay? So don't think of it as a line, it's a plane that essentially
Why
is
do we
like
have-
that plane.
So why is the rest of the figure not just flat on this plane? Why is it extending all the way back?
Because
to
the figure is a combination of them. So then the figure goes like that until it reaches this plane, and that's the limit of it.
Okay,
What was the
that's a pretty good
equation?
explanation.
Y equals to 2.
okay,
That's pretty good. That's pretty
is the x-intercept 0, 0, 4?
This right here?
Intercept, sorry, this z, no, there, like the
Here?
that's 0,
Yeah.
0, 4.
This is the intersection is x equals 1 and x equals, oh, is it negative 4?
Yeah, that's a negative 4.
And is that not in our?
No.
Why is it not in our graph?
Because we're only looking at the first octant. Octant, like this
Okay,
part of the three-dimensional.
okay.
We're not going to negative x.
But there's, what about 1?
The 1
That's where
is
it's intersecting.
where both of these intersect. So this here,
Oh,
y is equal, x is equal to 1. You can, if you want to think about that. And you'll, use that later. But. So then, if this is, so what is the coordinate for this? It'd be 1, 0, because we're at the origin, at the xz plane, right? Y is equal to 0, and then xz is equal to a 3.
wait, that's 0 on y?
Yeah, because we're in the xz plane at this point. At this point.
Okay.
Not here, but like there.
This is just such a bizarre way.
And like it's good to get exposed to it. Like, that's why we're doing this session. But
It sucks.
it's hard to explain it.
Okay.
So then
So how did
on this
you-
plane y is equal to 0.
Okay.
What?
Okay.
It's like combining 3 different planes and then putting them into one picture. But you have to draw it on a paper,
It's so
which makes it even harder.
Do you think if we just kind of like make it kind of small, and they can't really like see it that well? Like,
No. And then the other thing is though, if we are drawing this, okay, if we have dx first, how many integrals would we have?
oh, you mean
We'd have 2 integrals, right?
why?
If we're doing dx first, because that's the surface it would go through, and that's the surface it would go through, essentially.
Oh.
So you need to think it like that too. If we're doing dz would be one
Yeah,
surface.
When they say 2 integrals,
I thought you meant like would we have double?
Not a double integral, but
Yeah.
2 triple
I
integrals.
was like, how many integrals are you gonna have? We're gonna have 2, and I'm like, yeah, we're doing double integrals. Like,
And then other he was like, no, we have 3. Then I was like, yeah, 4. And next up, like, we were super.
And then if we were to then draw y and z, we would have how many shapes in here? 2.
Shapes? Shapes?
There are 2 shapes.
Why are there 2 shapes?
Okay, because you're
Is that top not flat?
Y, Z. Like you're standing on the X plane.
Yeah, like, if this
that
is
an
pressed-
angle? Is that top angled or is it flat?
This right here?
Yes,
That's a curve.
it's a curve, so you
Yeah.
do see part of it.
Yeah.
Oh.
So if we're pushing it back on it, we have
I remember.
the shadow of the curve
I was
and the flat surface that's going at an angle.
So would you would only need 1 integral?
So those would be
2.
2 integrals.
2 triple integrals.
But there-
Yes.
It's still just
times.
like a square.
So if we were to do dx, we'd have the first dx be say through this top region, the second this bottom region. Okay? So we'll call this region 1, region 2. And then in that first region we did the dx, right? So then our dz would be from this to there. From the bottom to the top. Starting here, going up here. And then our y would be from left to right. The second region, our dx would be the bottom section. Our dz would be from this, going up to this limit, and then y would be from left to right.
You can do 1 integral out of it.
There's a way to do this with 1 integral. That would be going from dz,
dz, dy, dx.
yeah,
That's fine.
no, dy, dz, dx, sorry. If we go from,
Yeah, that's already.
yeah, so the idea is to just get one shape in the next 2 like
So
plane, right? So if we do dy,
if you do DC first,
we did dz first. I think it would work with dz first as well.
DZ is 1 triple integral.
Yeah, dz is 1 triple integral. dy is also 1 triple integral
so
because we go through that way first. Then the xyz plane, the figure would just be like that, like that, and you could take care of that with the same in triple integral.
so when you have DZ
When you have dz first,
Wait, if you're doing, what do you have?
with the dz first,
Yeah.
you would
Wait,
have going up like that,
And
right?
it's just like,
The 1.
Yeah.
it's just like a square or whatever.
One, yeah, going up whichever. And then xy plane, the only equation that's covering everything is the top. So then you'd have a box.
And then if it was DZ, DX, DY,
then it'd be, you know, going from left to right
Yeah,
first.
Yeah.
Taking this class about typographics. I would not understand.
I'm taking graphics right now, and I still don't.
I mean,
I'm finished.
well, yeah, I had like 40.
So the whole thing is just
So which
Trying to
one would
picture
you
it.
take more than one?
if you do dx first, because
You go
dx
through that,
and then the
and
top.
then you have to hit the top.
Yeah.
For a lot of these, are they just gonna have a set deadline?
It depends. For this old exam, they're having you set it up. But for you do solve the double integral
But just the single one?
for two of yeah. So they don't ask you to solve the triple integral. They do ask you to solve a double integral. And one of them. Oh, never mind.
But is setting up a triple integral, that's just the three, you don't have to like get it down to one.
That would be solving it. Okay. If you have a double integral, and I tell you that the function is equal to sine of y cubed, does that matter?
Sign of what they're gonna do trig.
You put that-
Yeah.
you put that on
But to draw it, does that matter?
I don't
No.
know how to draw it.
But why doesn't it matter?
To draw it,
Because that's
you're-
just what you said,
yeah.
so that's it.
to draw it, you just need to look at the limits to find the function in those two planes, the x, y.
Oh, so you're given the integral.
Yeah.
So you want to draw it.
It's like the x thing that I did, right?
Yeah.
X is the slope of the function in the z dimension, but we wanted the shadow that it places on the region, right? So this is what I'll post, but I'm just gonna show you guys. So it's a double integral sine of dy of dx. So you have x and y, right?
It's a triple or no?
It's a double integral.
Sign of what?
Y cubed. Okay.
My bad.
You have to solve this.
So yeah, so we have the limit y equal to square root of x going to pi 1/3.
Oh my god.
X is equal to 0, pi 2/3, but that doesn't matter, okay?
Like 2/3 of pi.
I don't understand.
2 pi over 3.
It's to the exponent, I think.
Are you serious? Like the
I
cube
don't know
root
how
of
to
pi?
do that.
Yeah.
What the hell's the cube root of pi?
Do you plug those
It
pies?
since it's y cubed or something, it becomes pi. So
Oh,
But how do you plot y or pi on?
you
you just
what is pi?
It's just a constant.
Three
it's just a
root
It'll
line.
act just like
what
a
is the
constant.
cube root of-
Sign.
Okay? The lower limit going from bottom to up. Okay, bottom we meet square root of x. Okay? So then that is just this line.
Yeah, I get that.
The top is just y equal to whatever that is. So we can just draw a straight line, pi 1/3. Okay? That's so you don't need to get scared, say, by the function that's in there. Okay? Make sure you look at the limits to draw. And I'm gonna
No, I was gonna have a question.
because like that's on the old exam. We'll cover that. And I don't want because when you actually do it, I want you to forget that I drew it. Essentially.
He doesn't want us to have
Any other questions? Obviously, there's a lot. But do you guys at least get some basis of how you're supposed to think?
this was weird.
Thanks, Dan.
Yeah.
But I'm still there.
Dan the man,
There's
Dirty day.
taking a stand.
I'm dirty.
Ah, dirty day.
Um,
it's just a lot of thinking, and make sure you take your time to think through it.
what's the worst